So welcome students. So this question you are given that f of x is equal to a piecewise defined function which is 3 minus x square if x is less than or equal to 2, root of a plus 14 minus of mod x minus 48 if x is greater than 2. And this function f of x has to have a local maxima at x is equal to 2. If that is so, what can you tell about the value of a? That is the question. Least value of a is 2011, greatest value of a is 2011, a cannot be determined, greatest value of a is 2, 3, 4, 5. Okay. So now how do we analyze this question? So you can see that f of x is a piecewise defined function. When x is less than or equal to 2, you have the function 3 minus x square. If x is greater than 2, you have the function root of a plus 14 minus of mod x minus 48. So these functions are very easy to plot. So let us plot these functions. When x is, if you take the coordinate system, when x is equal to 2 or less than 2, when x is equal to 2 or less than 2, that is on this side, the function is 3 minus x square. So you know how to draw the function 3 minus x square. So this is the graph of y is equal to 3 minus x square, and this is valid only when x is less than or equal to 2. And when x is greater than 2, the function is mod x minus 48 negative of this plus root of a minus 14. Here a is a constant, so root of a plus 14 is a constant. So the graph mostly depends on mod of x minus 48. So you know how to draw the graph of x minus 48. So if you don't know, let me just clarify this. So mod of x minus 48, this is the graph of mod x. So if you have mod of x minus 48, the graph moves horizontally by 48 units. So this will be the graph of mod of x minus 48. Now minus of mod x minus 48, if you have a negative sign, the graph will just reverse. So this is the graph of minus mod of x minus 48, and you are adding some constant. So this graph will move up by certain units depending on the value of a. Now let us assume that a is such that you have some graph. This graph, this is my x is equal to 2. So if it moves by some units, the graph might start from this point. So whatever this point is, the value of y is root of a plus 14 minus of, if you substitute x is equal to 2, 2 minus 48 is 46. So root of a plus 14 minus 46. So this is the graph of this function. So depending on the value of a here, so this graph can move up and down. This graph can move up and down. So now, what is the question? F has a local maxima at x is equal to 2. So what is meant by a local maxima? Local maxima, the meaning of local maxima is f of 2 should be the greatest value. F of 2 should be the greatest value in the neighborhood of x is equal to 2. So when you take the neighborhood of 2, so in these interval, so you have some value of its, some functional value. So you have exactly f of 2 at 2. In the neighborhood you have a slight variation. So f of 2 has to be the maximum value within the neighborhood of x is equal to 2. So you can very clearly see that on this side, when x is less than 2, f of 2 is the minimum value, and in the neighborhood of, in the left neighborhood of 2, all the values, all the functional values are greater than 2. All the functional values are greater than 2. So f of 2 can never be the maxima. F of 2 can never be the local maximum, because in the left neighborhood of 2, you have functional values greater than 2. You can see that the graph is going up. So f of 2 can never be the local maxima. So f can never have a local maxima at x is equal to 2, whatever be the value of a. So if the value of a is small, so this graph can come down. This graph can come down. So f of 2 might be the maxima in the right neighborhood, but in the left neighborhood f of 2 cannot be the maxima. So if f of 2 has to be the local maxima, it has to be the maxima in both the neighborhoods. So the answer is a cannot be determined. You cannot have any value of a for which f of 2 is the local maxima. But if this question is asked instead of maxima, if you have minima, let us change the question and see what happens. So the answer to this question is C, but in the next time, if you get instead of maxima, if you get minima, then how do we have the analysis? So if f has local minima at x is equal to 2, that is, f of 2 has to be the minimum value in the neighborhood of x is equal to 2. So then you can very clearly see that in the left neighborhood, f of 2 is the minimum. In the left neighborhood, f of 2 is the minimum value. So if f of 2 has to be the local minima, the right neighborhood value should also be less than f of 2. So the condition should be the value of this, the y value of this should be less than 2. So this graph should come down, so that this value is less than f of 2. So that is, the value of y is root of a plus 14 minus 46 has to be less than f of 2. You can see that f of 2 comes from this definition. So if you put x is equal to 2, 3 minus 4 is less than minus 1. This implies root of a plus 14 is less than 46 minus 1, 45. This implies a plus 14 should be less than 45 square, that is 45 into 45, that is 25. So this implies a should be less than 25 minus 14, that is 11. So if f has a local minima at x is equal to, if that would have been the question, the value of a should be less than 2011. That is, the greatest value of a may be 2011. So a should always be less than 2011. So the greatest value of a is 2011. So depending on the question for now, because the question is given as maxima, it is not possible. So option C should be the right answer to this question. Thank you.